the other mic? Can we have the other mic for Jose? Yeah. So my name is Marko Tibold. I'm an engineer at Sanoma Technology, just like Jose. Yeah, as Sander mentioned, we were sent away all the way to the cold, dark north of Groningen. Groningen. Well, at night. For the Dutch blockchain hackathon. As it turns out, we are quite an innovative country, and the municipality of Groningen is really trying to boost innovation, especially on the IT/blockchain level. And they're really pushing it forward. For example, Chamber of Commerce was there present. Other, I think, ministries were also represented, or at least were financing it. One of our princes, the princess, Prince Constantine was there to also give it a bit of a push forward. Yeah, so we were there together with the team of Worksprout, and they had 2 slots available, and Serge was so kind to send us away there. Can you click something? I think just the arrow button. Whoa. Yeah. So, yeah, as I said, 55 teams, biggest blockchain hackathon ever organized. There were 5 tracks: identity, energy, future of pensions, international trade and entrepreneurship, and reinventing government. There were quite some interesting results from there. We were put in, of course, in the identity, well, not of course, but we were put in the identity track. At least we were supposed to be in there, but there wasn't much room left. But Worksprout, it's a company that matches user profiles of candidates that want to apply for a job with company vacancies. And they have user privacy in mind. So they don't want you they don't want companies to see all your personal data of your job information, your skill set, so that you don't get bombarded like you tend to get on LinkedIn, for example. Next slide, please. Yeah, so I'm going to move a bit this way. So the biggest thing that we learned about blockchain technology. So first of all, it's a blockchain. Is anybody aware of blockchain technology? Do you know a bit what it is? Has anybody heard of Bitcoin? Who has not heard of Bitcoin? Okay, everybody knows about Bitcoin. Bitcoin is the oldest kid on the block.
One of the oldest cryptocurrencies.
Yeah.
I think there were some.
I mean, switch it on, I guess.
Hello? Yeah, I was saying that there were actually a few cryptocurrencies before Bitcoin, like eGold, I believe, but I don't really think they ever got to mainstream as Bitcoin did.
Yeah, so what the biggest bullet on this slide is actually the shortest one. The learning curve is really steep, and that is actually was the case for us as well. We tried to come up with a working demo back then.
Between drinks.
Yeah, well, there were a few drinks, but I think Saturday around 1, we finally figured out the proper way to do blockchain tech the way it's intended. And that is a bridge to the next slide.
Yeah, the tooling ecosystem behind the blockchain technologies is actually pretty vast. So there are a number of client-side libraries, back-end libraries, but there are also a lot of pre-made tools like Docker images and etc. that allow to run private nodes like very easily as well. So
Yeah. Yeah, so if you want to do it properly, you will be running your own blockchain network locally, and you will develop against that. But to get that running, you need to align a few stars in the galaxy to do it right. There are some things that make it easier for you. So we have public JSON RPC endpoints that you can talk to from JavaScript code, and we figured that out around
Yeah, the
12. Well,
that is
yeah.
the well, the blockchain hackathon was actually mostly around Ethereum, which is a cryptocurrency also based on the blockchain, and they have two major public networks: mainnet, which is the one that runs the official cryptocurrency, but they also have testnet for people to develop applications against, which doesn't require people to spend any money to build applications and to test things around.
Yeah, so let's talk a bit about Bitcoin and how that works. So when you want to make a transaction, somebody needs to put that transaction of yours in a block on the ledger. And the ledger is the Dutch translation of ledger would be kasboek. That gives you a visual idea of what it actually is. So it's just a chronological array of these ledger pages, and each page is hashed. So a hash is generated, like we all know, like MD5 hashes. I don't know, it's probably some SHA hash. I don't know what the standard is, but this hash uniquely identifies this little bit of data, and the hashes of each block
they contain the hash of the previous block, and it's all digitally signed, so we can actually verify, the whole sequence of blocks. Unlike, for example, a normal database of records, in that each record is independent. In this case, each transaction can be verified, and that gives a guarantee that all the transactions are valid and no one manipulated the system. So that's why it's common for people saying that there's no trust required, because you don't need to trust any second or third party or a bank or an accountant. Everything can be verified programmatically, so which is a big advantage around trust, identity, and many other topics.
Yeah, so Bitcoin is around since 2008, I think. It was invented under the pseudonym Satoshi Nakamoto, and currently it trades at about $1,200 per Bitcoin. And yeah, it's the biggest one on the block, but yeah, I think we're going to switch to Ethereum. Oh.
Yeah, and an important note is that even though Bitcoin became very popular, there are also dozens of cryptocurrencies that might come and go, become more popular, disappear, become replaced. But the core technology that allows cryptocurrencies to work, which is the blockchain technology, was mostly the focus of the hackathon, and it's something that has been very stable and proven to be useful in lots of applications, and not only cryptocurrencies. So,
yeah, to give you a visual idea of the blockchain, so this would be it. So the hash. So there's all the way at the beginning. There's the so-called Genesis block, but then after that, blocks are added by miners. Miners are incentivized to do mining by awarding them with new Bitcoin, and each block points to the previous block, and it contains the hash that Jose just mentioned. But if you would say, if I would tweak this data in this block, then automatically the hash that's stored here would be invalid. Would be changed immediately, because the content of this block has changed. But if I would change a block like 100 or 1,000 blocks back, it would still change this hash over here. So that's how we are pretty sure that the data is not tangled with. Forking does happen on the blockchain world, which means that somebody else will mine, for example, when there's a network partition, somebody else will mine a block, and then you would get two parallel blockchains starting. And once there is some logic that determines which blockchain then wins and goes back to it, and I forgot, maybe you remember what it was, but I'm pretty sure, yeah, it's there. I believe it's the one that's...
Yeah, I believe it's network consensus, because people can actually manipulate the the people around the world can actually manipulate the blockchain data. But there's a consensus algorithm that runs on the networks, in that because each user of the system has a copy of the whole database. So the question is, which copy is the official one? And basically through the consensus algorithm, the copy which is valid is the copy that the most people have. So that becomes the official one, and that also makes it so that bad actors cannot manipulate the system, because the bad actors don't have as much as computing power as the sum of the computing power of the people that have the official copy of the database, which is the majority.
Until some evil-minded, professor comes and has a lot of computational power that he actually can go back in time, change the data, mine all the blocks behind it, and then present it back to the blockchain. But that case is very unlikely. Okay, let's just dive into the practicalities of the hackathon project we were responsible for. Well, the goal was to build a minimum viable product that stores profile data of candidates and companies. We wanted to use Ethereum smart contracts to store the data and actually have logic execute inside the blockchain, or actually on some node that is doing the mining. So what you have to bear in mind with Ethereum and smart contracts, the execution of logic is not happening on some computer locally or on a web server. It happens somewhere in the blockchain. And so the goal was to have do the matching and alert candidates about matching profiles between candidates and companies, and have them ask them for a consent, store the consent in the smart contract, and then send a notification to a company and give them access to access the data of the candidate to see who is a valid new candidate. So the paradigm shift we had to make. Traditionally, you have an application. We all have this kind of setup. There's a user with a web browser. There's an application sitting somewhere. With us, it's Amazon S3, Amazon actually, EC2, and then there's some storage. Now with blockchain technology, you could actually theoretically just cross this out. In the future, maybe 1 decade, 2 decades, this will disappear, and the user will talk to the blockchain. So the application logic will happen here somewhere in the node.
Or core parts of it.
Yeah. So that's the biggest paradigm shift because we started out and we started with we need a web server and a database, and we will talk to a blockchain through the application like this, and we'll figure it out. But then it turned out that it's really not so easy to take this old approach. You should actually go in the direction of just talking to the blockchain directly from a web browser. This is possible because there are nodes on the network that expose a JSON RPC endpoint where you can talk JSON to it. You post JSON data. You need to do some signing, etc. But then you talk to the blockchain network directly.
Yeah, I think a simple way to explain it, and even to explain what we are trying to do, is, for example, I believe that most of us have a LinkedIn profile. So we basically gave LinkedIn has all our data. And LinkedIn, they are the custodians of the data, even though there are legal agreements and etc. Either as a LinkedIn user or as someone that implemented some service on top of LinkedIn, LinkedIn is responsible for the data. And if we want to interact with our own data, we have to ask permission to LinkedIn. What the blockchain allows to do is to move the data and some logic with the related to the data as well, to a system that basically does not have a custodian, like a distributed public database that is basically not on a server that is owned by any private entity or anything like that. And that's the big paradigm shift between traditional applications and blockchain applications. So
yeah. So this is actually a repetition of what we just said. So this was our initial approach: web server, database, and have something in S3 or wherever in a hosting party do the actual interaction with the blockchain. And this was the final approach: talk to it directly from the browser and interact with it that way, and then respecting the distributed architecture of how it was all intended. So that summarizes that. A whole list of stuff. The most important thing is, if you want to use Ethereum, you need Ether. You can also sit on or make use of a testing network where you can get free Ether. Ether is the currency of Ethereum. To make a transaction, you need to pay for the computational cost that the miner is doing for you, and that is directly proportionate to the amount of ACLU operations.
Yeah,
ALU
bytecode operation.
Yeah. So when you create a contract, you compile it into bytecode. The bytecode goes on, is stored on the network, and it's and you can then trigger it. So the code is running inside a virtual machine, like an Ethereum virtual machine. That is, but it will be executed exactly the same on any node on the network. Oh yeah, by the way, it was invented by Vitalik Buterin because he was displeased with the way people were building protocols or blockchain protocols and constantly changing the protocol whenever there comes a new use case around. And then he said, well, let's just create something where end users can program their own protocol and put them in contracts. That's how Ethereum came to see the day of light. Oh yeah, very important. You need to specify a gas limit, because otherwise, if you don't do it and you write some infinite loop in your Ethereum contract, yeah, you'll just deplete your entire account. So you need to be. That's why you provide the gas limit, and you determine the gas price by yourself. But there's a recommended gas price. Otherwise, nobody will pick up your request. How are we time-based? 5 minutes. Okay. So yeah, any smart contract that it's posted on the blockchain gets an address just like any other account. The smart contract can store Ether, so you could just transfer funds to a contract, and then you might put some logic in that contract that whenever somebody sends funds from that from an account, you can store that account and the amount, and you can put logic in there that you send it back next month. I don't know, because you have, for example, a short-term lending thing. I don't know, something like that. Yeah, so it's, as we said, it's like a global distributed computer.
Yeah, because on the blockchain, apart from the hashes, you can also store data. So I believe that Ethereum uses this feature and allows to, apart from being able to utilize it as a currency, you can also store programmatic scripts in the blockchain that attach some behavior to data. So a smart contract, you can see it as a script that can read and write data on the blockchain, and it can also interact with other contracts. For example, you can, in regular banking, you can transfer money between account A and B. But for example, with Ethereum, you can, transfer some currency to an account, and you can also deploy a smart contract, create a script in that if something doesn't happen in 30 days, the money gets automatically retransferred back to the original account. So that type of logic, like that type of behavior, things like permissions and other context, it's something that you can do programmatically with smart contracts, and everything is verified cryptographically, so you can always ensure, access controls and security around this. So I think it's very interesting.
Yes. Okay, so this is the closest we're going to get to a demo. This is the bit of code that was written in Solidity. This is the code. This is the smart contract code that gets byte compiled and stored as bytes actually on the blockchain. Anybody can see this code. well, not the code, but they can see the byte compiled stuff and they can reverse.
Yeah, because every
reverse
node in the network, they can execute the smart contracts, and smart contracts are basically bytecode. And but you know, obviously they don't want people to program bytecode, so there are several languages that can be compiled to bytecode that are utilized to program smart contracts. Solidity, I think it's the most popular one, which is basically some form of JavaScript, but there are others that actually similar to Python.
There's Serpent, that is Pythonic in a way, and then there's a third one which I don't remember. So as I said, it's byte compiled, stored on the blockchain. In this code snippet, a candidate, we have defined a struct of a candidate and a struct of a company, and there are two functions where a candidate account is added to the contract, stored in the contract, and a company account. So to register, state will change on the blockchain, and hence it will cost somebody some gas. However, if we would have written a function that lists the total amount of companies registered with a WorkSprout team, that would be something that doesn't change any state, and it can be run locally on any node, and so that's free. You don't have to pay for that. You can go crazy with this actually, because this is just a very small part of what you can do with the language and the logic.
Yeah,
there are limitations, of course.
Yeah, the language itself is a little bit limited for several reasons. For example, you know, for technical reasons, the computing power of the distributed computer is equal to the computing power of a calculator in the 80s. So, and then there would not be anything that would stop someone for creating an infinite loop, for example. That's why there is the concept of gas, because when the smart contract is compiled to bytecode, there's some value that gets attached to each bytecode operation, and the sum of it cannot be more than the limit of gas price. So each time a bytecode operation executes, a little bit of gas, which is currency, gets deducted from the value stored on the smart contract, and basically when the smart contract runs out of gas, the execution of the smart contract fails. So that ensures that, you know, that basically ensures that no one can overload the system.
Yeah. So this is the last slide. Just some ideas that we just wrote down quickly. The list is actually infinite. What you could imagine is the cadastre. You can put it on the blockchain, where we register each piece of land and each home that anybody owns, and we would then replace the notary? Notaris? No, the notaris. Yeah. The notary. So because we now need somebody that we put our trust in, because notary is very honorable, and everybody trusts him, but he costs a lot of money, etc. But that's why we can trust him. And you can better put your trust in the blockchain and automate that away, and I don't know, send him on pension. I don't know. But you could also put your will, instead of you give your will to the notary, you could program your will. You could say, if I am not checking in frequently enough, every 3 months, I probably may have died. And I want all my funds to be transferred to my ex-wife. I don't know, for some weird reason. But she needs an Ether account, of course. And yeah, you could program everything in there. Or you say, anything that's related to trust and authentication and authority, registering membership of any club or union. This is one I heard over a podcast. In the future, we will have self-driving cars that are completely autonomous. The revenue that they generate gets transferred to the address of the car, and the car just keeps making more money, and nobody needs to own the car. That could happen. and anything you can come up with. And then finally, we have a few ideas for pointers for Sanoma maybe in the future.
For example, I'm a developer at Sanoma account, and we are custodians of how many million accounts? And I think in 2018 there will be some new legislation regarding, user data privacy and etc. So, for example, if we move the user data to the blockchain, and somehow technically we would make the users the owners of their data. So at the moment we are the custodians of the data, and if the user wants to interact with the data, he has to ask us for permission and use our own applications. But if we put the data on the blockchain, the users will be custodians of the data. There will be access controls managed by the user to who and when can someone access his data. So we would basically become clients ourselves instead of being the servers. And from legal perspective, that could save us quite a little bit of trouble. So and since all the data on the blockchain is also public, it could be good for transparency as well, and we could even implement some things on top of it, like Sanoma coins for subscriptions, paid content. So.
Yeah, or giveaways, for example. Prijsvragen. Yeah, that's it, I think.
Yeah, and there are some other technologies based on blockchain, like distributed file systems, so which could replace S3, and etc. Questions?
The other questions over beer? Well, we ask I see a few questions in the back.
Yeah, so I'm fairly new to blockchain, so I don't know anything about it except for what you just told me and Bitcoins. But can anybody read the information that is in a block, or is that?
Yeah.
Yes.
So.
Information is public.
So in terms of storing user profiles in blocks, that's not a real good property of a system.
So that layer is something that the blockchain doesn't concern itself with, but it's possible, for someone to encrypt the data before putting it on the blockchain, and then to decrypt it back.
But then you need somebody to govern that again, right? So that defeats the purpose of.
Yeah, I guess you're right, but I think you need applications to interact with the blockchain anyway. So I think that's the responsibility of the application layer.
Yeah, and so if you